So, very good morning to all members gathered here. Today we are in the next lecture, projection of solids in engineering graphics subject. We are going to discuss about the basic importance of projection of solids. So, in the previous lecture, we were discussed about orthographic projection, and day before yesterday we saw about isometric projection. So now individual must be knowing the comparison between iso and orthographic projection. Now using these different projection methods, now we will try to apply our ideas in projection of solids. So before moving to the topic, let us have an idea what do you mean by the solids? What are the different classification of solids? A solid is nothing but it has three different dimensions, say length, breadth, and thickness. All the three are tightly packed by surfaces that can be of plain surface or curved surface. Sometimes combination of both the thing. So to represent a solid on a flat surface, so we can go with two different dimensions, say length and breadth. So for that, at least we require two orthographic view that is considered to be one of the most important mandatory thing. So now we will come to the next level of discussion in the following slides. So as I've told you, there are different classification of solids. First one, solids of revolution. Here we are going to have three different category of solids: round, sphere, cylinder, and cone. So these things will be comes under solids of revolution. Next one is a polyhedrons. A solid object will have multiple face or multiple sides. Therefore, it is classified as polyhedrons. Can take cube, prism, and pyramid comes under polyhedrons. Now we will discuss about the projection of solids subject to basic simple position. There are three boundary conditions: axis perpendicular to the horizontal plane, axis perpendicular to the vertical plane, and axis parallel to both horizontal and vertical plane. So among which we will discuss any one the boundary condition with a simple elementary example. So we will take the first one, axis perpendicular to the horizontal plane. So in this problem, a triangular prism. So for this triangular prism, we have to draw the projections in 2D. So the base dimensions of triangular prism, all the three sides are considered to be 40 mm equally, and the height of the triangular prism is 50 mm long. Okay, so the axis is resting perpendicular to the horizontal plane, and with the one of the vertical face facing perpendicular to the vertical plane. So we will try to see this diagrammatically, the concept for understanding the question. See the pictorial projection. So this is what the isometric or pictorial projection. So to understand the problem statement, okay, so consider two reference plane, horizontal plane and vertical plane. In between the two plane, the triangular prism is resting. So what is the condition given here? The solid axis height of the triangular prism is facing perpendicular to the horizontal plane, and one edge of the triangular prism is facing perpendicular to the vertical plane. So this is the basic condition given here. So for this, we need to draw the projections of solids, that is triangular prism, by showing top view and front view separately in orthographic mode. Now let us see the solution. So based on the problem, it is quite understood that axis is perpendicular to the horizontal plane. So we shall start drawing the top view as a first priority. In this case, the top view gives the true shape or true image of the solid object. So draw the top view, and then from the top view, finally we can construct the front view with the help of the projection lines. See, when the observer viewing from this direction, from the top view direction, you can able to get the sides ABC, the triangle ABC, and DEF are the invisible sides. So draw the top view by showing an equilateral triangle ABC. So this is the final top view. Now from AB, from C, draw vertical projection line up to XY line. Then from XY, we need to draw the front view. The front view looks like a rectangle prism. So how to view the front view? In this direction, horizontal direction. So this is the front view. So when you view from the front, DEFCA, the rectangle, this portion will be completely visible, whereas EFBC is the invisible edge. So draw a rectangle ACFT. Okay, this is the required front view and the top view of the solid object in orthographic projection. So you can see the steps here. Project the front view, which will look like a rectangle, and name the corners accordingly. So from this information, what I conclude that projection of solids involve a thorough understanding about how three-dimensional objects can be drawn in a better way by means of two-dimensional drawing, and we must have the basic key aspects in knowing the positioning of views in isometry. Then only we can able to plan and draw the front and top view of the solids in orthographic. So one has to be very thorough with the basic projection methods. So with this, I thank each and everyone. We shall meet in the next lecture in the same course, Engineering Graphics. Thank you all.